In this episode, I'm going to take a look at the built-in functions for charts and diagrams in QGIS. But I will start to just mention the plugin Data Plotly. That is a plugin created to be really powerful when it comes to charts and diagrams. It builds on the D3 library, and when installed, you can select a lot of different types of diagrams. Here I have just a violin plot, and there are a lot of settings. You can do many things. For instance, it can be set up to be interactive with the map. So depending on where you zoom to and what you have selected, the diagram will update according to that. And yeah, it's really powerful for situations when you have a lot of data. In this case, I will be using very limited data and very simple diagrams. And I have created a GeoPackage with a project file that looks like this. So this GeoPackage you will be able to download it and use it as an example, or just use the data like I will do to recreate these diagrams. And there will be a link in the description for where you can find all this data on the GeoPackage. So let me see, where did I have my charts and diagrams? There we are. So first of all, I will use just a simple points layer, and the attribute table for this is very simple. It's just an A, B, and C attribute with some integers. And the first thing I would like to do is to create a pie chart for those, for each point. Layer styling is done in the layer styling panel, and here you also have labels, but charts are in the layer properties. So either right click and select properties, or just double click on the layer. There's also keyboard shortcuts for it. Here you have a diagrams section in the layer properties, and you can select a few different diagrams. I will start to focus on pie charts, but I will quickly glance over, for instance, the text diagram. So first of all, when you create a diagram, you need the attributes for it. And to add attributes, you just select them and click the green plus sign to add them to the right side. And if we choose text diagrams and apply, this is the way they will be portrayed. And I haven't played with text diagrams that much, so I will just mention it here. So let's switch back to pie charts. Now we see that. In this dialog, you can change the legend text, and that will affect what is shown here. There is no function to automatically set different colors here. Maybe it would be helpful to have a color ramp selector or something like that, but it's pretty easy to create your own colors. So in this case, let's go with lightly blue for the first one. The second one, let's sample the first one and tweak the hue a bit to the right for the first one, and sample the same and tweak it to the left for the second one. That way they match and fit together. But you can use any method you want to make your colors coherent and matching. Yes, rendering. You can change the opacity for your diagrams or charts. You can change the line color and the line width any way you like. For pie charts, the default is they start at the top and go clockwise, but you can change this here in the settings. You can quite easily add draw effects in the same way as you would for features in QGIS otherwise. So for instance, a drop shadow with a little less opaque shadow is quite easy to add like that. Visibility is when you have perhaps overlapping diagrams. You can control the drawing order or in what order they are drawn on the map. I haven't played with this to any extent to be absolutely certain of what it does, but show all diagrams is, for instance, necessary if you want overlapping diagrams to be visible. And then the Z index can be used to control that the order of the diagrams. Show diagram is also a way to override this checkbox so that specific diagrams according to an expression can be shown or disabled. And this always show is also something that can be used to have data-defined overrides for. You can also use scale-dependent visibility in the same way as you could for labels, for instance. The size for pie charts is the default is a fixed size. So let's say 30. When you apply that, all the charts will have the same size. It would perhaps be nice in some situations to have the overall size reflect the sum of the values. And in those cases, you can scale the size either to a single attribute or you can use an expression to add everything together. So A plus B plus C. That could be the base for the size. And you can click here to find the maximum value and say that that maximum value should equal 30. And then you can scale it. So smaller sums will be portrayed as smaller pie charts. If you get a lot of really, really small pie charts, you can set a minimum size so that they will always be visible at a minimum size. Placement around the point or over the point. If you select over the point, yeah, that will be always centered over a point. And if you have a different kind of geometry, we will look at that later, it will look a bit different here. But around the point, I will leave it at that for now. The coordinate here, I'm not sure what it does. I haven't had that much success in tweaking this. I'm not sure if it's an absolute coordinate or if it's relative, but you could tweak the placement coordinates in some way with these overrides. The same with priority for the placement. If you have other charts that should be placed at the same locations, you can give your pie charts a higher priority and they will then be drawn first. In the same way that label can be discouraged from covering features, that can also be controlled with this data-defined override. Depending on your pie chart, you will have different options. So for pie charts, there are no options, but for histograms and stacked bars, there are. And we will look at those a bit later. But we'll go back to pie charts. Legend, as a default, you will only get the color patches for A, B, and C in this case. But you could also play with settings for the shape of the pie charts. So you can use separated items or collapsed legend. So let me change this to a white color. And if you don't want the automatic classes, you can use manual. So I don't have any smaller ones, so let's just add 20, 30, and 50, like that. You can align them at the bottom or the center, but bottom looks better. And you can change the line symbol for the call-out line. So maybe you want that to be dot line, like that. And if I apply this, you will see it show up here. But there's an issue. The size for this should be 47, but it's a lot bigger. 50 is a lot bigger. And that has to do with the size unit. So right now it's millimeters. And if we switch to a layout, let's just add a layout, add the map, like that, and a legend. And the legend should not auto-update. Remove that, and that, and that. And let's make that background go away. If I place this above here, you will see that now the legend is correct in size for the diagrams. And that is because the unit is millimeters. And when you view it on the screen like this, millimeters don't matter. So if I change this to pixels and apply, I need to add some size, 130. Now they are more in line with each other. The issue now is when you go back to your layout and update it, it looks okay, but if I change this zoom level, the symbols change as well. So one option could be to find another setting. Oops. And I thought I could use points for this. Let's change that to 80. But as you see here, they are not really the same. And if I switch back to layout and update, they look more the same and they behave the same when I zoom. But for screen, pixels are the thing that works the best. Let me try if map units work. And then I'm guessing I should make it a lot bigger, yeah. then it works, looks like it works here. Nope, does not. But it will probably work in the layout. Yes. So if you're working with a screen like we are doing now, you should stick with pixels if you are using the legend symbology like this. So let's see how polygons work. So here we have some polygons. The attribute table is very similar to the points, A, B, and C fields with some integers. And let me change the default color here. And let's add a histogram for this one. It works the same for the attributes. We select the desired attributes for the pie chart or the histogram. And in the same way as before, I will pick the color from that one, and let's go darker and more saturated for the first one. And the second one, we will use that and go this way. And the third one, let's use that one, and go even further. And nothing shows when I press apply. And that is because for histograms, there is no fixed size option. You need to have a scaled size. So if you haven't an attribute selected, nothing will be shown. So let's use the previous sum of the values, find the maximum value, and let's try 30. Should we use pixels here as well? And say 100. Let's say 200. Okay. In the let's see, rendering, you can still do opacity like before, but now we have bar width and bar spacing. So I think these are too skinny. Let's say make them at least 3 times as big. And the spacing should be only 1 and should be pixels. How does that affect this? Yep. So maybe 2 pixels between. Yeah, that's fine. A line width, let's make it really small. And let's add some draw effects. Drop shadow is nice, but it should be very small and not as blurry, but less opacity, less opaque. Like that. And we can change the axis, but I can also turn all axes off. Like that. Minimalistic and nice. Then you have the same as with pie charts with visibility in Z-index and show diagrams and scale-dependent visibility and so on. For polygons, you have a few more options when it comes to placement. You can do it around the centroid. You can do it inside polygon. You can use perimeter, but I'm guessing you don't want to do that because that's confusing. Or you can place it over the centroid. And depending on what you select here, you can add a distance to it as well. but over the centroid, that's more or less like over the point for the pie chart previously. Same problem here. I don't know how this coordinates work. You can try it yourself if you think you need it. Otherwise, the settings here are the same as for the pie charts. Options, you can do it up. You can do it... Hello. Up, down. Why doesn't it work? Something is really bad. Yep. Okay. Something locked up. Anyway, you can change it to down, right, or left. I will stick with up. And in this case, the legend are the color patches as for pie charts, but you will not get a nice graphical depiction like for pie charts, or you will get exactly the same depiction as for pie charts, but it's just confusing to use them in this case. So for anything except pie charts, I suggest legend not enabled, like that. Stacked bars is a kind of a bar system, but they are on top of each other. So instead of separating it by horizontally, it will be vertically. And you can play with it, the settings here. But I will leave it at histogram, like that. Okay, moving on. What if you have overlapping points? In this case, I have more than 4 points. And if I select here, you can see in the table that there are 4 points at the same location. Here there are 3 points, 2 points, and 1 point. So how does it work to add pie charts for points that are really, really close or overlapping? Well, it works pretty good. So let's add some pie charts with the attributes as before. And this time we will use something on the red scale, I think. A bit more red and like that. Less color. Yep. And pick that one and move it to the pink. I use that one and move it towards the blue. Let me just change the line width to 2 or 0.1. Shadows are nice. Let's add some shadows. A bit too dark. Nope. Shadows. Just like that. It looks like there's only one pie chart for each point, and that's because they are all stacked on top of each other. And if we change the size to a scaled size like before, use the same expression, A plus B plus C. Find the biggest value, and that should be 100. You will see that there are 4 here, 3, 2, and 1. But they are placed on top of each other. And that is because we have a 0 distance here. So just by adding any distance, let's add 2 in this case, and apply, they have the ability to space out. So just add any distance. The more distance you add, the further away from the point they can place themselves, and they will follow some form of math. So top right, then bottom right, top left, bottom left, in that order. And if you have more than 4, just increase the distance until you can see them all. If you select over point, they will all be stacked on top of each other. But let's move on. If you have overlapping points as before, there are 4, 3, 2, and 1 point in the same location. But instead of showing one pie chart for every point, you may want to show a pie chart with the sum of value A, or let's take B, that's more interesting, for the points that are at the same location. Can you do that? Yes, you can, but it's a bit more involved than just clicking a few buttons. So we will still go into the settings for pie chart. I will place it over the point right away, and then we will go to the attributes. But instead of selecting the A, B, and C, or the B, I will use an expression. And as for everything in QGIS, when you are working with more than one feature, you will use the aggregate function. So let's add aggregate, and that takes a layer value, an aggregate function name, an expression, a filter, a concatenator if you use concatenation as aggregate function, and an order if you want it. We will use all of these. So first of all, the layer, go to map layer, and this is overlapping points 2, comma. Then we will have the aggregate function, and if we check the help file here, you can see there's a lot of aggregate function, and the one I want in this case is concatenate. That will add strings together. So the aggregate function should be a string, so concatenate as a string. The next part of the aggregate function is an expression, and the thing I want to aggregate is the values in the B attribute. However, concatenate works for strings, and the B value is an integer, so I need to convert that to string. To string, like that. Next, this will concatenate every B value, and I don't want that. I only want the values that are at the same location. So I need a filter here. And to test if an object has any other objects at the same location, we need to test the intersection. So that function is intersect. And we will test if the the parent geometry. So the geometry for the parent, and the parent is the object that is running the aggregate function. And we will run that on the layer we have named. And for each feature in that layer, we will test the geometry if that overlaps the parent geometry. So it doesn't matter if it's the same layer. The parent geometry is the one that we are starting with for the aggregate function. I hope that at least made some form of sense. Just trust me when I say that use intersects geometry for the parent and the geometry. That will work. Then we will use a concatenator, and let's use a comma. And I want to do this in the order from smallest to largest. So let's just sort them by order in the B attribute. This will generate a string that is more or less an array, but it is a string, and in order to turn it into an array, we need to use the string to array function. String to array, and it should be like that. Now we have an array. In this case, I'm assuming that in no place there will be more than 4 points that are within this intersects function. So I will need 4 values here to assign the attributes for the pie chart. And I need a function that takes the first one, then the second one, then the third, and the fourth one. And that is done by the function array get. So array get, and for this first function I want to use the first one, and that has the index 0, 11. But now it's a string, and the attributes here should be an integer. So I need to convert it back to int, like so. Now I have the first one, the first point, point 1. Now I just need to add another one for the point 2. So let's use the same function, but index 1 for the second point, P2. Add another function, the same expression, but index 2 for the point number 3, P3. And the fourth and final one, the same way. Add the expression and index 3 for the fourth point in the list, P4. And let's just change the colors. Should we go for something earthy this time? Let's do the size as well. Scale size. Here we can't use the a plus b plus c and so on. We need to do something that has more or less the same expression as before. So let's start with the same expression. But this I will want to use all of them, so I don't need the array parts or the array get part. So let's just remove all that. and I don't want to concatenate it. I want the sum, and I can't make a sum from a string like that. I don't need to concatenate or sort it by order. So there's the sum of all the overlapping points. And let's find the biggest one and make that 100. Nope, that's too big. Let's make it 550. No, it should be 100. I forgot to change the pixels. Like so. So let's take a look at this. Here we have 4 pie slices because there are 4 points. 3 for 3 points and 2 for 2 points. One thing here, there are 1 pie chart for every point. So if I change the rendering opacity here, you will see that this is much darker than this one, and that is because they are stacked on top of each other. If I change the placement to around the point and add some distance, you will also see that there are 4 pie charts here. So the simple solution is to use it over, and you could also use some clever expressions to filter out only one diagram per point. I will not try to do that here because I haven't prepared it, but that is one possibility. And if you manage to do that, you can add draw effects as previously, because if you do that now, the shadow for the pie charts will be much darker where you have several pie charts. Maybe you can do that by not multiplying, just using normal. What will happen then? Nope, didn't do anything. So bear that in mind. The simple solution, if this is what you want, is just to place them on top of each other. And if you have a lot of points, as usual, aggregate function will take some time to render, but in this case, it's pretty quick. You may want to explain this a bit further than just P1, P2, P3, P4. So in this case, I will also look at labeling. So let's add some labels, and nothing is showing, and that is because charts are seen on as they are more or less labels, so they are overlapping right now, and we need to allow that. So right now the mode is never overlap. Switch that to allow overlaps without penalty, and something will be shown here. In this case, I don't want the FID like it is. I want to have values from all overlapping points. So let's start with the same aggregate concatenate function as before. I don't need that one, and I don't need that. Now we have some form of start here with the values, but instead of toString, I will add a string that says FID and use the attribute FID remove that parenthesis, and we will add another string with a colon like that, and so, and maybe add a new line character that is \n. That could be nice. And the comma, I don't need that. So the concatenator can be nothing. And I want to place it to the right of each diagram. So let's place the label offset from point to the right. And I could increase this to a value that's semi-suitable for all, but since they are of different size, it's more natural to use an expression here. So let's override it and use let's see, not that one. This one that aggregates the sum of everything. I think that is too big, and since the value is the area, I will square root it. Square root the value. And 8 is probably a bit small, so let's take that times 2. And it should be a string of doubles or an array of doubles. So let's create an array. And the second value is y, and that should be 0. Like that. Yep, that looks okay. And now we have the same issue here where we have overlapping labels because there are 4 of them here. So maybe if we never overlap, yep, that will work. And we can change fonts as we usually do with labels. Let me see. Did I want to go through anything else now? I don't think so. So the data I've been using, there will be a link in the description, so you can download that GeoPackage with my example styling, so you can see what I have been doing, and you can try this for yourself. And hopefully it has brought some light to the built-in functions for diagrams and charts in QGIS. And I'll see you next time.